afternoon, students. Once again, I have come with the new video. This is for class 11 physics. This is elementary chapter. Since you can say this is first chapter, second chapter also, because first chapter is physical world. So far, I have made some videos from chapter 1 also, physical world, like forces in nature, fundamental forces in nature, and conservation's law. Now, it is in second chapter, that is unit and dimension. This is class 11 physics. Date is 21st May. This is lockdown period. And hope you all are fine. And me too, I am also fine. So let us start a dimension. Let's start unit and dimension. But before going inside the topic, I would like to tell you very like elementary things which you have to understand before going in this chapter or in this topic. That is measurement. Hope you know the measurement. Measurement is simply a process. Measurement. It is simply the process. It is a process by which we can compare some unknown quantity with known reference quantity. Here you can say it is a process by which we can compare some unknown value of quantity with the known reference value of quantity or reference quantity. This reference quantity is known as a unit. Okay, and unknown quantity means suppose we have to purchase 1 kg of potato. Then to purchase 1 kg of potato, what we will do? We simply asking the shopkeeper, I need 1 kg of potato. They are just giving a potato by comparing it with the some known standard reference quantity. You can say this reference quantity is also known as standard reference quantity. This another word also you can use, standard reference quantity. So standard reference quantity, you can say there is some particular devices or there is a particular some things they are keeping in a bin balance and they are comparing. Sometimes they are comparing with the spring balance also and they are doing the measurement. So this standard reference quantity is also known as unit because this value is already determined. The standard reference quantity means these values already determined. These values already determined. We no need to determine these values. Only just we have to compare with the determined value, the what value to be measured, that to be compared with these values, means whose value is already determined. And this value already determined means there are many examples, like we are comparing a length with the meter scale. We are comparing or we are taking the time and the standard unit of time we are taking seconds. Then we have year, month, week. Then we have to measure suppose any quantity we are taking in terms of mass. Then we have a pound, kilogram, then gram. So we have a lots of lots of quantity which can be measured with the comparison of standard reference quantity. Actually, after taking the measurement, that measurement will not be signified, or its value or its meaning will be meaningless if we are not representing that particular measurement with the along with the unit. So unit is very important. is length. Suppose length is coming in a magnitude, suppose 5, then we have to represent this 5 in terms of meter or centimeter or kilometer. This meter, either we are writing meter or kilometer or centimeter, etc. This will give the meaning to this 5. So our measurement can be signified or our measurement will be meaningful after writing that measurement in terms of unit. Means unit have a very special importance. The importance is that it gives the meaning to the measurement. So importance of the unit is, before going to write the types of unit or whatever, no, it's importance to be, what is its importance that to be known. So importance means, what unit importance means, unit gives meaning to measurement. And students, we have a lots of process to have the measurements. Here I am not going to discuss that because it is already you have studied in the measurement chapter. But even I would like to emphasize on today some types of unit. So there are two types of units. Means here types of unit. So there is fundamental, and one is derived. So one is fundamental unit and derived unit. Fundamental units are some basic fundamental units are specified with the 7 fundamental units, or you can say this value is fixed. Here 7 fundamental units are there. So the 7 fundamental units are means length, mass, time. These are called basic fundamental, and fourth is like current. Fifth is temperature. Sixth is amount of substance. And 7 is intensity of light or intensity. Just only we can write intensity. So intensity we are measuring in candela. Simply amount of substance we are measuring in mole. Temperature Kelvin. Current ampere. Okay. Time we are measuring in second. Mass we are measuring in kilogram. And length is meter. But students, I would like to emphasize once again, these quantities can be measured in terms of 3 basic process: MKS, FPS and CGS. And later on there is SI unit. So I have written all the SI units for you. Okay? And derived unit means there are many derived units. Derived unit means the unit which is formed from these 7 fundamental units. Like as for example, so first I will write these units are formed from fundamental unit. As for example, velocity. So velocity have meter per second unit. Like force has Newton. Force is Newton, or you can write kg meter per second square, like that. So derived units are many units. Means once we are starting to study the physics, like many physical quantities it will come. That quantities to be written in terms of their unit, that will be derived unit. And there is also the fundamental units, but fundamental units are very limited. The limited fundamental units are 7. And apart from these 7, basically you can see these 3 units are repeatedly coming: mass, length and time. Then later on you will get current and temperature, and then you will get all these in 7 fundamental units. And now I am going to use all these particular units, particular measurements in terms of dimension means dimension. How to represent dimension? What is dimension? And how it can be written to the physical quantities that I am going to discuss. So our main focus is today is dimension. So very basic things I have told for unit. Hope you have understood this. Now let us move to the dimension. So for dimension, first of all we should understand dimension. What is dimension? Okay. Dimension simply we are telling it gives like shape or by knowing the dimension we can say that there is a volume or the shape, okay, for the particular quantities. Yeah, it's the same things we are going to explain, but in terms of the fundamental physical quantities means any quantities in the physics, that quantity have a like a base. The base is fundamental quantity. So that particular quantity can be written in terms of that basic fundamental quantity. Okay, so let us come to the dimension. Dimension. So dimension means the representation of physical quantity. Physical quantity. Do you know the physical quantity? The quantity which can be measured. The quantity which can be measured. The representation of physical quantity in terms of fundamental physical quantity or fundamental physical quantity or unit is known as dimension of that quantity. As for example, I have told before, like speed. So speed, the general formula is distance by time. And distance is itself length. Because distance, breadth, thickness, okay, like height, these all are the same quantity. They have to represent in terms of the same units, like either meter or centimeter or kilometer or millimeter. Okay, so distance is ultimately length. So length by time. So I mean to say this speed have two fundamental physical quantity. One is length and one is time. So if the speed can be represented in terms of this length and time, then the representation is known as dimension of speed. But what happens whenever we are writing the dimension, we have to give the specific notation here. The specific notation includes one big bracket. So here a specific notation we have to give, like a specified notation is for dimension is like big bracket. We are using big bracket. If you see the books, many books, you can find the dimension of any particular quantity is written in terms of this bracket. So my point is that if I am trying to write the dimension of the particular physical quantity speed, then I have to write speed in terms of speed inside this big bracket. Then I can write length. Then I can write here time, again big bracket, and then length is itself length means then length we are represent L and time for T. So its dimension is L T equals 1. So dimension of speed is L T inverse 1. Now the question can be arises, how to know what to be represented for which quantity in terms of dimension. So let us see that. It's It's very easy. I will write here for the 7 fundamental physical quantity which particular symbols to be used to write the dimension. So here now here so symbols for dimension, symbols for dimension of fundamental physical quantity. So like first is mass. So for mass we are representing with capital M. Then length. So for length we are representing with L. Then time we are representing with T. Then current we are representing with A. A is ampere. Temperature. So here we use SI, that is Kelvin. So K. Okay. Then intensity. Here also we use CV. Okay. Then amount of substance. Here for amount of substance we use CD. Okay. Mole. Okay. So this way we can use symbols for the dimensions of fundamental physical quantity. Once we know the symbols for fundamental physical quantity for its dimension, then we are able to write the dimensions. So there is very few the simple steps to be followed. With the help of that, we can write the dimension of any physical quantity. Whatever the physical quantity is there, their dimension can be written very easily. But there are some limitations of dimension also. So we will discuss the limitation of dimension also. So now I will just do 1 or 2 examples here so that you will understand the steps to write the dimension. So here steps to write the dimension. So steps to write the dimension. Steps to write the dimension. So steps to write the dimension. So number 1, first step. First steps, the physical quantity must be written inside the bracket. This bracket. Like example, speed. I have to write then speeds. Next, at least formula of that physical quantity to be known and written correctly. So we have to write the formula for this speed. As for example, like this speed I have written here. So here the formula is for distance by time. So distance by time. Third, use the symbols of fundamental quantities. In second step, I have written at least formula for the physical quantities to be known and written correctly. This to be written in terms of fundamental quantity. And any formula like suppose like acceleration if we are writing. Then acceleration we have to write in means the formula must be written in terms of fundamental quantity as much as possible. Like I have written here. So distance means this is length by time. So later on you can write here t to the power minus 1 is the dimension of speed. So by following these three steps, we can write the dimension of any physical quantity. Okay, with the help of these three steps, I'll just give you the two more examples here. So let us see the another examples. The simple examples or any examples we can take here. Like suppose I am writing for force. Next example is force. So force. So I have to write force first in the bracket. Then I have to write formula. Formula is mass into acceleration. So here mass is itself a fundamental quantity, no need to change, but acceleration is not a fundamental quantity. So again we have to change it. So again I will write here mass, and for acceleration I have to write velocity by time. Again bracket. Again velocity is not a fundamental quantity, so we have to change in terms of fundamental quantity. So we will write here mass, and velocity means this is the distance by time. So distance by time, and then here is time again. Now this time and this time will multiply, it will be square of the distance, square of the time. So mass into, now distance fundamental quantity is length. So length by time square. Right? Now force is written in terms of fundamental quantity. Now let us use the symbols. So second step, mass is 4 m, length is L, and now time, so time is t square. So it is L t to the power minus 2, because reciprocal I have said. So this is the dimension of force, which is the dimension of force. Now again I am using another example for pressure. So now one more example is pressure. So students, once you know the dimension, then you can use directly also that dimension. So like pressure, so I have to write a dimension for pressure, then pressure to be written in terms of bracket, inside the bracket, then pressure means force by area, so I write here force by area. So here is two methods. Now either I can use directly the dimension of force, okay, or I can write the force in terms of fundamental physical quantity, then I will use symbol and then I can write. So it will take a long process. Let's do both of the process, right? Process first. So process first means force can be written in terms of fundamental physical quantity. So again its formula is mass into acceleration. Then area means either, if suppose the area is length into breadth, or breadth into height, or height into thickness, whatever the formula is here, definitely it comes length into length. I have told you, because height is also length, distance is also length, displacement is also displacement is another point. But even if we are writing displacement, means unit will be same. So height is also same, breadth is also same, thickness is also same. Whatever we are writing, our unit will be same. So that's why in terms of that I am telling the quantities are same. So area here it will be length into length. So area will be length into length. Okay. So mass is already fundamental. fundamental quantity. Acceleration is velocity by time. Velocity by time. And this will be length into length, means I will write length square. Length square. Then velocity is again, we have to write distance by time. So mass into distance by time and whole by length square. Length square. So this time and this time will be square. Okay. It is not going to cancel out because here is also one slash, here is also one slash. So here mass will be mass, fundamental quantity itself. Distance is length. So distance is length. Time, then it will be time square. Time square, then divided by length square. So one length and one length will cancel here. One length and one length cancel here. So mass I will write here. One length is already gone. So here is time square. So it will be m by t square divided by 1 is m. 1 is m. So I will write what? So the final dimension will be L minus 1 t to the power minus 2. So this is the dimension of pressure. And now if I use directly, so directly also I can use here. So force is like m t to the power minus 2. Already we have done. And area is L square. So I can write here m 1L cancel. So L minus 1 t to the power minus 2. So this way we can write the dimension of the particular quantity. Okay, let us use one more example. So one more example. Like one example I am writing for torque. Torque is very important quantity. You will study in the next chapter. Okay, and in 9th class also you might have studied this torque. So torque is tau. This is a vector quantity. So torque we are writing generally force into perpendicular distance. Means force into perpendicular distance. Now students, I use direct dimension. So directly dimension. So if we use directly dimension, force is m L t to the power minus 2, perpendicular distance is distance L. So it will be m L square t to the power minus 2. So this way we can represent the dimension of any physical quantities. Okay. Now then, what is the main importance of the dimension? Since we already writing the formula, we have a unit, no? So how to use this dimension, or you can say that means what is the importance of the dimension to be used, then why it is used in a physics. So there is three main importance of the dimension. So let us see that importance of the dimension. And students, in between the importance of the dimension, limitation also will come. Okay. So first importance I am writing here. Importance of dimension. Importance of dimension. Okay, so number one, dimension can be used to check the correctness of the physical formula. Here physical formula. Here I am putting a star. The meaning of a star means dimension will not be considered for integers and the physical function. So we are not able to use here we are not able to use the dimension for integers, any integers, because there are two types of constant and two types of variables. One is dimensional constant and one is dimensionless constant. One is dimensional variable and one is dimensionless variable. I will tell this also. Let me complete this. So, and trigonometric functions like y is sin omega t, like equation y is a sin omega t. So here for the sin omega t we are not able to use the dimension. Suppose y is phi k b c. So phi will be dimensionless. We cannot use the dimension for integers. Like suppose log x is ab. So for this type of equations we are not able to use the dimension, and it can be used for limitation of dimension also. Okay, later on also again I will discuss for this point. So, but we have to emphasis on the dimension can be used to check the correctness of the physical formula. Okay, so dimension can be used to check the correctness of physical formula. We have a main physical formula. Now let us see its explanation. So we have many physical formulas. Okay, like very simple formula I am going to use. Suppose you have given that y is ut plus half at square, where y is distance, a is acceleration, t is time, and u is speed. Okay. Now number one. Number two is y is ut square plus half at square. Now question is there, it to choose one of the correct equation. Okay, we know that y is ut plus half at square is correct equation because we have studied many times. We have studied this equation in equation of motion also, graphical method also we have calculated this, and from the beginning only we are studying this equation. That's why we can see directly and we can say this is correct. But with the dimensional analysis, with the help of dimensional analysis, this equation is correct or not, that we have to check. Okay, so there is a very simple method. Okay, with this method we can say product of this equation is correct and this equation is wrong. Let us see how. So to use this, first to check the correctness of the equation. Now what we will do, the first we will do means we will check all the physical quantities is known or not. Here y, u, t and a. Here also y, u, t and a. So here is 3 physical quantity, 1, 2, 3, 4 physical quantity. Here also 1, 2, 3, 4 physical quantity. This t is repeating. Okay, this t is repeating here. Here also this t is repeating. So I have marked only u, t, a. Okay. So 4 physical quantities are here. Here also 4 physical quantities are here. And equation have 2 parts. One is this LHS. You can say left hand side means this is LHS, and this is both the RHS. RHS have 2 terms. First term and second term. Okay, 2 terms are there. Okay, so step by step we will write the dimension of each terms in LHS also, in RHS also. Maybe some equation you will get in that equation in LHS may have the 3-4 terms. Maybe you will get an equation in LHS also and RHS also with the same terms. So whatever you can use the same method. So let us see, students. Already we know the quantities. There are 4 variables. Equation is to be checked is y is ut plus half at square or y is ut square plus half at square. Here are the variables. So I will write the dimension of variable first. So y is distance. So its dimension is here. U is dimension is L t to the power minus 1. I have told you for half no dimension because this is integer. No dimension. A is acceleration. So A is acceleration. We know its dimension L t to the power minus 2. Or if you have forget the dimension, then you can use the first steps, 3 steps. With the help of that, you can get it the dimension of this. T is time. T is time, so its dimension is t. Okay. Now, in LHS and RHS, this is you mark it as a first equation, and this is the second equation. For first equation, we'll use this dimension in the both side. So y means L on left hand side. Then right hand side, u use L t to the power minus 1. Then t is t. Then plus half no dimension, so forget it about. Now A is L t to the power minus 2. And then again t square, so I will put square here. Okay, because since t is square, so we have to put square here. Now let us do the calculation here. Here no need any calculation because single term, so L you can write again. So L and L is not here, so L is L. T to the power minus 1 here is 1. So it will be t to the power 0. Plus here is L, here is t to the power minus 2, here is 2, so 2 is cancelling, means power, so t also will be 0. Anything have a power 0 means it will be 1. So here L plus L, it will be 2L. Again there is no dimension for 2, so L and L. So dimensionally left hand side and right hand side the equation is same. Means equation is giving same value on left hand side also and right hand side also. So we can say this equation is correct. Now you can ask sir, how do you know that this equation may not be correct? Because once this equation is correct, definitely this equation will not be correct. Because here is the power 2. Here is the power 2. Now this way also if you check the dimension, means if it is a length, all these sides should be length after having the calculation. But here 1t is more. 1t is more because length is multiplied by time, then only distance will come. Length is multiplied with time, then only speed is multiplied with time, then only length is come. Speed is length by time, then if you multiply speed with time, then only length will come. And if I put a square here, then it won't be equal. It won't be equal. That's why this equation is correct. Now let's come to the second importance. So second importance means we can derive the physical formula. Okay, by using dimension we can derive the physical formula. But the physical quantity should be stated, or physical quantity should be given in terms of the statements. Means here second use means with the help of dimensional method or dimension, we can derive or derive a physical relation. Here also I will put a star. A star means the relation which to be determined for that physical quantity should be known with minimum dependence. You can say with dependence means the physical quantity was what to be, or physical quantities. I mean to say here writing quantity, it will be better to write the physical quantities. So how many physical quantities are going to relate in in the particular equation, that to be given in terms of their dependence. मतलब at least the minimum relation should be stated. Minimum, like y is depending upon x. How depending, that I am not asking. Like y is depending upon x. Okay, maybe here I can write like y depends upon x. Y depends upon x. If this much is given, means we can write the relation for this. Okay. So let us see the meaning of this star once again will be clear here. Suppose example means the time period of a simple pendulum depends upon length and acceleration due to gravity. Acceleration due to gravity means then find the relation among time period and given physical quantity. Okay, means this is the question. Now by reading the question only you can understand the spirit of the second importance of the dimension. Means if this much here, just only a simple statement is given. This depends whether they are directly depending or like inversely depending, that is not given. Okay, so we may find the relation between all the given quantities. Let us see how. So here also a very simple technique. The simple technique you can use to find the relation among the given statement or given physical quantity. So students, here is three physical quantities. The physical quantities are, first of all I am writing here like answer or solution. Means physical quantity is time period of simple pendulum. So time period is, I am writing t. Okay, time period dimension. Then length is given. So length is L. And then acceleration due to gravity. So acceleration due to gravity. So this is z. Now the question is that time period is depending upon. So time period is depending upon time period is depending upon length of thread of the bob. So that means t is, suppose here time period is t, small t you can represent, and then this is the dimension compromise t. So all better to write t only, no problem. So L. Now here I have written directly proportional, that is wrong. So I have to put here A, B, C. Means the value of A may be 1, maybe 2, maybe 0, maybe minus. So the value of A is any values. So A will may have any integral value or fractional value, positive or negative. Okay, so whatever the constant I will use here with the same meaning. Now time period is depending upon length is done. Now time period is depending upon z, so z I will put here b. So b will have any value, any numerical value. better to write numerical value. Any numerical value, whether positive also, negative also. So this is your one equation and this is the second equation. So I relate these two equations. So T is proportional with L to the power A and Z to the power B. Now I have to write here the physical equation. So I have to remove this proportional sign. So I will write simply T is equal to any constant where L is A and Z is B. So K is a constant. Those value here, like such type, this is the standard equation we are going to derive. So here the constant value is already known. Okay, so that value I will write here. Since the value is coming 2 pi, this is coming from the simple harmonic motion equation. So T is equal to L to the power A and Z to the power B. Still this equation is not formed. Now to form the equation, we will use this dimension formula all here. So now I am putting the dimension of E all. So here the dimension can be used here like T is proportional with T is equals to K L A Z B. So dimension is T. Then K is a constant. No need to write the dimension. So K written itself. So L is L to the power A. And now Z. So G is acceleration due to gravity. So this is acceleration only. So its dimension will be L T to the power minus 2. Power is B. Now K, here L to the power A and here L to the power B. So this is simple algebra. So you can write L to the power A plus B and T to the power minus 2B. Here is T. Students, as we know that if I write here L to the power 0 and T to the power T, then this side K, L to the power A plus B and T to the power minus 2B. So here the bases of the equations are same. The base of the equation are same, so their power must be same because here is equal sign. So with the simple algebra you can write A plus B is 0 is one equation and minus 2B is 1 is another equation. So here is B is minus 1 by 2 the value. So the value of A will be 1 by 2. Now we put this value B and A. The B and A here. So T will be K times L to the power half and Z to the power minus half. Means K will be root over L by Z. So this is your required expression. If you don't know the value of constant, that won't matter here. If you know the value of constant, that is better. Or if you don't know the value of constant, that won't matter here. But your equation is this. And since the standard equation is T is 2 pi root over L by G. So this is the equation for time period of the equation. Okay. So this is the second importance of the dimension. Now let us come to the third importance. So now so using here one more thing I would like to tell means again logarithm function or any trigonometric functions that cannot be derived with the help of dimensional method. Now third is by using dimension we can convert the value of physical quantity from one unit system to another unit system. मतलब एक यूनिट सिस्टम से दूसरे यूनिट सिस्टम में हम ले जा सकते हैं वैल्यू को. जैसे कि as for example like force is here is 1 Newton. Okay, so this is represented in SI unit. Then if I write in CGS, then how much dyne in CGS. So this fill in the blanks can be filled with the help of this dimensional method. So let us see how. So to get it this, first of all we have to write one physical relation between two unit systems. They are equal. They are different unit system, but they are equal. So they are equal with this magnitude. With this magnitude. So I can also write whatever they are in a different unit system. Okay. So if their values are written in terms of unit, then I can write like n1 u1 is equals to n2 u. Whatever their values, whatever, like it may be rs, it may be rupee, paisa, but because of this n1 and n2 is values, magnitude of u1 and magnitudes of u2. So this can be written. Now suppose this u1 is represented, or u1 is written in terms of like SI system, and now this is u2 is written in CGS system. So if we know whether they are written in SI system or CGS system, we can use the equation. But if we don't know, then we have to go for the general formula. So general formula means in each equation it has mass, length and time. Okay. So I am writing here like n1 is suppose mass m1, L1 and T1. So all have the power A, B, C. All have the power A, B, C. M1 have A, L1 have B, T1 have C. Is equals to N2, and we can written as M2, L2 and T2 have a power A, B and C. A, B and C. Now this is our equation. So with the help of this equation, any one unit system can be converted into another unit system. Now question arises, how to know the value of ABC? The value of ABC will come from by knowing the system, also by knowing the physical quantity, because x1 and x2 is a physical quantity. So if we know the physical quantity, we can write the value of A, B and C. So I will do one example here. So example is like force is equal to 1 Newton. 1 Newton, it is, now I have to write into dyne. How much dyne it will be. So force is written 1 Newton. So you can use N1 is 1. Newton is physical quantity here. Physical quantity. So physical quantity we have to choose. We have to see. Suppose here force is given 1 Newton, or maybe they give like that only 1 Newton. Now we have to see, and we have to find what physical quantity it is. So it is force. It is force. So first we write physical quantity is force. Physical quantity is force. And once it is written in terms of SI system. So it is written in SI system, and we have to convert into CGS system, because this is dyne asking CGS system. Now first write the dimension of force. So dimension of force is m L T to the power minus 2. So I have told you that before, the value of ABC is coming from here by knowing the physical quantity. So its value is here, power is 1, so value of A is 1. So A is 1. The power of L is 1, so value of B will be 1. And the power of T is minus 2, so C also will minus 2. So these values work here also. Okay. Now put all this value in the system or in our given equation. Then we have to convert it. Now what we need to find? So we know M1, L1, T1 here. M1, L1 and T1. So M1 is definitely kg, because this is SI unit. So we write unit of kg. L1 is definitely meter, so we write a unit of meter. T1 is definitely 1 second. Now we have to convert into M2, L2 and T2. Definitely T2 will be, so M2 will be written in terms of gram, then only we can write the dyne. Then L2 will be into centimeter and T2 will be in second. So 1 kg is 1000 gram, because we have to convert now, and it is 100 centimeter. This is 1 second. Now let us use it. So we have to find this N2. So N2 is M1, L1, T1, A, B, C divided by M2, L2, T2, C, B, A. Now the value of M1 is 1. Now M1 is already here 1000 gram. 1000 gram. The power is A, and the value of A is 1. L1 is 100 centimeter, 100 centimeter. So here what we can write? The value of b is 1, and then t is 1. So 1 to the power how much? Minus 2 divided by, this also will be in gram. Okay, have a power 1 centimeter, power 1, and then 1 is the power minus 2. And then the whole system is going in terms of dyne. The whole system is going in terms of dyne. Since it is written in terms of Newton before, now once we are changing, what we are changing into dyne. So we have to write dyne here. Then gram we cancel, centimeter cancel. This also already cancelled. So here is 3 to 5. So 1 into 10 to the power 5 dyne. So this way we can convert like 1 Newton. Like 1 Newton we can convert into dyne. So dyne will be 1 into 10 to the power 5 dyne. So this way we can use the third importance of the dynes. Now once again I am telling the summary. The summary is that first importance means we can use to check the correctness of physical equation. Second is we can derive the physical relation, but the relation should not contain any type of logarithm functions in both first and second, trigonometric functions, or like any integers, or we can neglect the integers, like it can be considered as a dimensionless. Now let us come to the significance or limitation of dimension. Limitation of dimension. Limitation of dimension. So we have some limitations for the dimension. So first limitation is dimensional method or dimension cannot be used for any trigonometric equation or any logarithmic equations. Okay. Now second, so dimension cannot give the idea to physical quantity, whether it is vector or scalar. Now third is very important, that dimensionally correct equation may not be correct. Dimensionally correct equation may not be correct, but dimensionally wrong equation is always wrong. So dimensionally correct equation may be wrong, but dimensionally wrong equation is always wrong. So dimension have these three limitations. Okay, the very important limitation is that it cannot be used for any type of trigonometric functions or logarithm functions. Then next is it can give you the it can't signify any physical quantities in terms of vector and scalar. And dimensionally correct equation may not be correct, but dimensionally wrong equation is always wrong. Okay, so hope you have enjoyed this video. Okay, one more thing I am forgetting here. In between video I have told I will tell the types of constant and variable. So students, there are two types of constant. There are two types of constant. The constant types means one is dimensional constant, and one is dimensionless constant. One is dimensionless constant. So how all the integers value like 5, 1, 2, half, all integers value, all integers. Okay, all integers value, they have the dimensionless. Or like any sine function means trigonometric functions. Trigonometric functions. Trigonometric functions. Okay, log functions. They do not have the dimension. A dimension constant. Now there is many constant which have a dimension like G, like Z. G is universal gravitational constant, but it has a dimension. Like Planck's constant, it has a dimension. So like Z, what is the dimension of G? So G have a unit is Kg. So you can write this way. So F is Z m1 m2 by V square, means you can write the dimension of G will be force dimension means Newton meter square per kg square. So its dimension will be this way. Like force first you have to write m l t to the power minus 2. Then meter square will be l square. Then it will be m square. Now you can calculate it. So it will be like how much? So minus m to the power minus 1, m to the power q, and t to the power minus 2. So this way it has a dimension. But some of the constant they do not have the dimensions. Similarly, there is a variable also. One is constant variable, one is dimensional variable, and one is dimensionless variable. The like velocity. Velocity is any physical quantity, but it is variable. We don't know how much velocity. So velocity have a dimension, means it will be l by t. But I am writing x. Okay. So x is maybe 2, maybe 3, maybe 4, maybe 5. Okay. The value of x is varying from 2 to 10. Okay. So it will not have the dimension. So we have hope you have enjoyed this video and hope you have understood few discussions of measurement also I have included in this video so that you can understand nicely the dimension. And thank you for watching this video. Once again, I would like to give you thank you that you are staying at your home in this lockdown period. This is a very crucial period. We all are suffering from that. So you stay at your home, stay healthy. Thank you so much.